Welcome to the lesson activities for section 6.2. This is for Math 204, differential equations. Okay, problem 1 is to make a list of all the Laplace transforms that we know so far, and there should be 5 of them. Okay, so let's see, the first one we learned was the Laplace of e to the a t. And that is 1 over s minus a. And then we also worked on deriving the Laplace of t. Okay, you did that in the activities of 6.1. And that came out to 1 over s squared. And again, another one we did in the activities was the Laplace of 1, which is 1 over s. And then today we derived the Heaviside function, the Laplace of ua of t, which remember that's the piecewise 0 and 1, depending on the value of a is where it switches. And the Laplace of that was e to the negative as over s. And then finally, this last one is the one that I just gave you in the demo earlier in 6.2, but I didn't want to derive it. Okay, so it said that the Laplace of the Heaviside function times e to the negative k times t minus a. That is e to the negative as over s plus k. Okay, so the next problem is to solve this initial value problem using a Laplace transform. y prime plus 7y equals u2 of t, and y of 0 equals 3. So if we're going to use the Laplace transform, you generally start by taking the Laplace of both sides. So I have the Laplace of 7y of y prime plus 7y equals the Laplace of u2 of t. Okay, so the Laplace of y prime is s Laplace of y minus y of 0. And then I have plus 7 Laplace of y. So I'm just taking the Laplace of both of these terms. So the Laplace of y prime is s Laplace of y minus y of 0. And the Laplace of 7y is 7 Laplace of y. Okay, equals. All right, and then the Laplace of the Heaviside function is e to the negative as over s. So this is going to be e to the negative 2s over s. Okay, so next I can replace y of 0 with a 3 because that is given. So s Laplace of y minus 3 plus 7 Laplace of y equals e to the negative 2s over s. All right, so I want to gather my Laplace of y's. So I have two terms that have a Laplace of y in it, one that does not. I'm going to move this one that does not over to the other side, and then these two that remain, I'm going to factor out a Laplace of y. So I have Laplace of y times s plus 7 equals e to the negative 2s over s plus 3. And then to solve for Laplace of y, we divide both sides by s plus 7. So Laplace of y equals e to the negative 2s over s times s plus 7 plus 3 over s plus 7. Okay, now this one is a straightforward inverse. I can take the inverse Laplace of this pretty quickly and easily. This is just the 3, think of it as a coefficient, 1 over s plus 7. The inverse Laplace of that would be e to the negative 7t. Okay, so let me just write that out. So y is going to be the inverse Laplace of e to the negative 2s over s times s plus 7 plus 3 times the inverse Laplace of 1 over s plus 7. Okay, so just picking up from our previous line on the previous page, this first inverse Laplace is going to require a bit of partial fractions to break it down, but the second one, so this first one I'm just going to leave for now as the inverse Laplace of e to the negative 2s over s times s plus 7. But this second one is a pretty straightforward, look it up in the table. This is 3e to the negative 7t. Okay, now the inverse Laplace that I have left, I need to break up using partial fractions. So I'm actually going to do a little aside here. So e to the negative 2s over s times s plus 7. That's the same as e to the negative 2s times 1 over s times s plus 7. And then this 1 over s times s plus 7 can be broken up using partial fractions. So it's going to be a over s plus b over s plus 7. Multiply both sides by the common denominator, so we get 1 equals a times s plus 7 plus b times s. And then just pick some values for s, and you can solve for a and b. Actually, I don't want to do that. Okay, so if s were negative 7, I would have 1 equals 0a minus 7b. So b is negative 1/7. And then if s were 0, I would have 1 equals 7a. So a equals positive 1/7. So then I'm going to come back up here and say e to the negative 2s times a over s would be 1/7 over s plus b over s, which is negative 1/7 over, s plus 7. Okay, so what I'm going to do next is remember our goal is working on this inverse Laplace transform. So I'm going to rewrite this equation here, and I'm going to replace what's inside of these brackets with a version of this. Okay, I'll do it on the next page. Okay, so I replaced what was in the brackets with a version of what we got by doing partial fractions. I pulled the 1/7 out of the fraction, and then I distributed the e to the negative 2s. Okay, so that means that we can now do the inverse Laplaces. I'm going to pull out the 1/7 through the Laplace. So I have y equals 1/7 inverse Laplace of e to the negative 2s over s minus 1/7 inverse Laplace of e to the negative 2s over s plus 7. Now these two inverse Laplaces, we know. We can look these up in a table. All right, so the first one, the inverse Laplace of e to the negative 2s over s, that is the Heaviside function, u2. So that would be u2 of t. Then I have still minus 1/7 the inverse Laplace of e to the negative 2s over s plus 7 plus 3e to the negative 7t. All right, so this one is the tricky, like the kind of yucky looking formula that we looked at and I just gave to you without driving. So this is e to the negative as over s plus k, and we can look that up in a table or in our notes, and we get, okay, so it's the Heaviside function with the subscript being the a value, the 2. So it's going to be u2 of t times e to the negative k. So in this case, k is 7, so negative 7 times t minus a, so t minus 2, plus 3e to the negative 7t. If you want to make this look like the answer in your packet, we just have to factor out a 1/7 u2 of t. So we're going to have y equals, I'll put the 3e to the negative 7t first, and then I'll say plus 1/7 u2 of t. Okay, so I'm factoring out 1/7 u2 from here and here. So this is the entire term, so if I were to distribute, I would need a 1 here, minus, here I just need an e to the negative 7 t minus 2. And now it looks just like the answer in the packet. Okay, so we have another initial value problem that we are to solve using a Laplace transform. So we take the Laplace of both sides. I'm going to move that minus y to the left. So this is the Laplace of y prime plus y equals the Laplace of 2 u3 of t. Okay, so the Laplace of y prime is s, Laplace of y minus y of 0 plus the Laplace of y equals the Laplace of 2u3 of t. So that's 2 times e to the negative 3s over s. Okay, so I can now replace y of 0 with a 4, so I'll go ahead and do that. And then I'm going to move the 4 over and factor out a Laplace of y on the left. So I'm going to have Laplace of y times s minus 4. Oops, I'm moving the 4 over. Laplace of y times s plus 1 equals 4 plus 2e to the negative 3s over s. Now I'm going to divide both sides by s plus 1. So I have the Laplace of y equals 4 over s plus 1 plus 2e to the negative 3s over s times s plus 1. Now I know what the Laplace of y is, I want to know what y is. So I take the inverse Laplace of both sides. So y is going to be 4 times the inverse Laplace of 1 over s plus 1 plus 2 times the inverse Laplace of e to the negative 3s over s times s plus 1. So this inverse Laplace, 1 over s plus 1, is straightforward. That is e to the negative t. So I have 4e to the negative t plus 2 times the inverse Laplace of e to the negative 3s over s times s plus 1. All right, to get this inverse Laplace, this last piece here, I need to do partial fractions on 1 over s times s plus 1. I'm going to get a new page and do that. 1 over s times s plus 1 equals a over s plus b over s plus 1. So we have 1 equals a s plus 1 plus b s. And then if I make s -1, I get 1 equals negative b, which means b equals -1. And if I make s 0, I get 1 equals a. Okay, so I now know a and b. So this would be 1 over s minus 1 over s plus 1. All right, so I'm going to take that result and put it into our previous equation that we were working on. Okay, so I have brought over our previous line from trying to solve the differential equation for y. And now I'm just going to substitute in here, knowing the partial fractions breakdown of 1 over s times s plus 1. 1 over s minus 1 over s plus 1. So I'm going to put that in here. So I've got y equals 4e to the negative t plus 2 times the inverse Laplace of e to the negative 3s times 1 over s minus 1 over s plus 1. And then distribute that negative 3s into those two fractions, and we have y equals 4e to the negative t plus 2 times the inverse Laplace of e to the negative 3s over s minus e to the negative 3s over s plus 1. And then I can take the inverse Laplace of these two terms separately. These are both forms that you can find in the table of Laplace transforms that we know. So this is going to be y equals 4e to the negative t plus 2 times, okay, the inverse Laplace of e to the negative 3s over s. That's the heaviside function. That's u3 of t. Minus e to the negative 3s over s plus 1. That's the one that's kind of like the heaviside function. The heaviside function is part of it. It's going to be u3 of t times e to the negative k. So this is a, 3, and that goes here. So this is u sub a of t, e to the negative k, so that would be a negative 1, times t minus a, so t minus 3. And then we just need to simplify this a little bit to make it look like the answer in the packet. So to simplify, I'm just going to distribute this 2. I don't know why I'm doing this. I'm just going to factor it back out again with the u3. Okay, so now I'm going to factor out a 2u3 of t. So I have 1 minus e to the negative t minus 3.